Hey guys, it's Cassie with Math OMG. Today we're going to be learning about vectors. Specifically, we're going to be looking at how to write a vector and how to calculate its magnitude. Here is a really nice image of what a vector kind of represents. You have a terminal point and you have an initial point. That would be this point here. The terminal point is kind of where it ends. And then the vector, how you write it, is you find the distance of A, so the distance between the x coordinates and the distance of the y coordinates. So that's what we're going to be practicing. That's the first thing we're going to be asked to do. So it wants us to show that these two arrows, RS and PQ, are equivalent. So the first thing to kind of observe and take notice of is that we're given two vectors and each contain coordinate points. Our mission is to prove that they're the same, so we need to prove that each vector has the same coordinates. And then our game plan for doing that is to use this formula. So when we use a formula, and that should say use the fact, not the factor, use the fact that each vector is represented by this. So you take the x coordinates and you subtract them, you take the y coordinates and you subtract them, and that's your vector. So if they're the exact same points, then we know that the vectors are the same. All right? So here's an image of it just so we have a better understanding of what it looks like. And from the image, it looks like they are in fact the same. They're parallel, they look about the same length, but we need to make sure. So to do that, we're going to use this formula. So I'm going to do RS first. So R is -4, 2. So that's going to be my x1, y1. And then S, my ending point, is going to be my x2, y2. So I am going to take that and I am going to subtract those. So I am going to do -1 minus -4, comma, my y value, my y2 is 6, minus 2. And that is going to give me -1 minus -4. That becomes an addition problem, so that would be +3, 4. So RS, the vector of RS, is 3, 4. So now I want to check to make sure PQ is the same. So PQ, again, my x1, y1, x2, y2. So it's going to be 5 minus 2, comma, 3 minus -1. 5 minus 2 again is 3. And then 3 minus -1, we end up adding those, which gives us 4. So we can in fact see that these vectors are the same. So that's good. We've proved that these are the same vectors, so we are done with this problem. Thank you guys so much for watching my videos. If you want to get better at math, subscribe to my videos here. If you want more information on math, click on my website link here.